Hello everyone. This is the third section of the chapter organizing data, that is organizing quantitative data. Uh, as you know, data is of two types, qualitative data and quantitative data. In this video, I am going to discuss some methods for organizing quantitative data. Okay, to organizing quantitative data, we first group the observations into classes and then treat the classes as distinct values of qualitative data. Several methods can be used to group quantitative data into classes. In this lesson, we discuss three of the most common methods. Okay. All right. The first method is single value grouping. The second method is limit grouping. The third one is cutpoint grouping. Okay, these three are the most common methods that we use to group quantitative data. Okay, let's go one by one. Okay. Let's move to the definition. The relative frequency distribution of quantitative data. A relative frequency distribution of quantitative data is a listing of the distinct values and their relative frequencies. A relative frequency distribution of quantitative data is a listing of the distinct values and their relative frequencies. This is the formula that we use to calculate the relative frequency. The relative frequency equals frequency divided by the number of observations. Relative frequency equals the frequency divided by the number of observations. Okay. The first method that we are going to use is single value grouping. Okay. In this method, we use single value classes. Each class represents a single possible value. Okay. In single value grouping, we use single value classes and each class represents a single possible value. Okay. Let's move on to an example of single value grouping. Here are some data in the table that contains frequencies and relative frequency distributions for the number of TV sets in each of 50 randomly selected households. Okay, according to the data here, the number of TVs are 0, 1, 2, 3, 4, 5, and 6. Yeah, that is the number of groups that we have with respect to number of TVs. Okay, from 0 to 6. And let's get the frequencies of those. Now let's begin filling the columns of frequency and relative frequency. As you can see, 0 appears only once. Okay, only in this scenario. So the frequency is 1. Okay, then 1 appears 16 times. So the frequency of 1 is 16. Similarly, we can fill the rest of the frequency values as 14, 12, 3, 2, and 2, 4, 2, 3, 4, 5, 6 respectively. Okay, that's how we calculate the frequencies for each category, each number of TVs. Okay. I've discussed the formula to calculate the relative frequency earlier in an earlier slide. It's frequency divided by the number of observations, right? Yes. So we can calculate the relative frequency of 0, number of TVs, by 1 divided by 50, which is 0.02. So that is 1 divided by 50, that will get 0.02. For the next one, the relative frequency is 16 divided by 50, which is 0.32. For the number of TVs 1, the frequency is 16, and the total number of observation is 50. So this 16 divided by 50, that will give you 0.32. And similarly, we can do the rest. 14 divided by 50, 12 divided by 50, 3 divided by 50, like that. We can get the relative frequency. And the summation of those relative frequencies should equal to 1. Okay? Alright. Now let's move to the second definition and also the second methods that were used to group the quantitative variables. That is limit grouping. Okay, that is defining classes using class limits. Here each class consists of a range of values. We call the smallest value of this range the lower limit, and the largest value of this range is the upper limit. Okay, that is the definition of limit grouping. Okay, there are some definitions that we used in limit grouping. Lower class limit is the smallest value that could go in a class, as I said earlier. The upper class limit is the largest value that could go in a class, and the class width is the difference between the lower limit of a class and the lower limit of the next higher class. That is, we call the class width. And class mark, the average of two class limits of a class. We call that as a class mark. Okay, these are some definitions that you should be familiar with when you're using the limit grouping to group quantitative data. Okay, now let's move into an example of limit grouping. Okay, this table shows the days to maturity for 40 short-term investments. Okay, the next table, the table that appears right now, shows we can classify these days to some intervals so that we can take each interval as a class. As you can see, the first interval is from 30 to 39, then 40 to 49. Likewise, we can write them up to 99. 30 to 39, 40 to 49. Likewise, we can write them up to 99. We started from 30 to 39 interval because the smallest value in the data set is 36, and the last value is the last interval is 19 to 99 because the largest value is 98. We should note that the smallest value and the largest value before we creating those limit groups. Okay, because when we are creating our limit groups, all those values should be included within those limit groups. Okay, that's why we should consider about the lower value and the upper value. Okay, all right, now let's start counting the numbers of each range of intervals. Okay, for 30 to 39 there is only one, that is 38. Oh no, right? No, there are two. No, there are more than two. 38, 39, 36. Yeah, there are three, right? In this 30 to 39 group, 3 tally marks, and the frequency is therefore 3. So the first interval 30 to 39 contains 38, 39, and 36. Okay, so the frequency is 3. Then for the next interval 40 to 49, there is only one observation, that is 47. So the frequency is 1, right? It's easy as that. The third interval is 50 to 59. So there are 55, 56, 51, 57, 53, 50, 55, and again 51. So there are altogether 8 observations within the range of 50 to 59. So the frequency is 8. Continuing the chalice, for each class we get the frequencies in the third column like this. For 60 to 69 there are 10, for 70 to 79 there are 7, for 80 to 89 there are 7, and finally for 90 to 99 there are 4. And finally the total observations can be taken by getting the summation of the frequency column, that is 40. Then we can obtain the relative frequency table. We can get that by dividing frequency by the total number of observations. Like this, 3 divided by 40, that is 0.075. Like that, we can obtain the relative frequency as we did in our early example. We can get our relative frequency column. And the summation of the relative frequency column should be equal to 1. Right? Okay. Alright. Now consider the interval 50 to 59. Okay? We are taking an example of considering the interval 50 to 59. The lower class limit is 50. The upper class limit is 59. The class width is 60 to 50. Okay? 60 minus 50, that is 10. Okay? The class mark is 59 plus 60 divided by 2. That will give you 54.5. Okay? Alright. Those are the definitions that we get, that we learned earlier. The lower class limit, upper class limit, class width, class mark. Yeah. Those are very simple things that you should be familiar with when you are dealing with limit grouping. Okay? Alright. Now let's move to the third method of grouping quantitative data, that is cut point grouping. Okay, in cut point grouping, this is same, but no, it is very similar to the limit grouping, as it has classes with a range of values, but here the smallest value of a class is called the lower cut point, and the upper cut point of the class is the smallest value of the next higher class. Okay, that is the only difference between cut point grouping and the limit grouping. Here in cut point grouping, we have the smallest value of the class is called as the lower cut point, and the upper cut point is the smallest value of the next higher class. Okay? Alright. There are some definitions that we can use in cut point grouping. The lower class cut point, the smallest value that could go in a class. Okay. The smallest value that could go in a class. The upper class cut point, the largest value that could go in the next higher class, that is equivalent to the lower cut point of the next higher class. Okay, the largest value that could go in the next higher class, that is equivalent to the lower cut point of the next higher class. And then the class width, the difference between the cut point of a class, the difference between the cut points of a class. And finally, the class midpoint, that is the average of the two cut points of a class. The class midpoint is the average of the two cut points of a class. Okay? Alright. Now we are done with the definitions of cut point grouping. Let's move on to an example. In this example, data on weights and heights by age and sex in the document vital health statistics. Weights in pounds of 37 males aged 18 to 24 years. Okay, so there are 37 data, weights in pounds of 37 males aged from 18 to 24 years. Okay, and the weight is categorized into several cut point groups: 120 under 140, 140 under 160, 160 under 180, like that. And then we are going to calculate the frequency of each of these categories. So here the smallest value in this data is 129.2. So we can take 120 under 140 as the first interval. And the largest value is 278.8. So the last interval should be from 260 to under 280. Okay. Now let's check the frequency for each interval. There are three numbers that is going within the first interval. Okay, that is 129.2, 136.7, 132.1. Okay, so the frequency for the first class is 3. As we did in the previous example, we can calculate the relative frequency straight away because we know there are 37 males, so we know the number of observations. The frequency divided by the number of observations will generate you the relative frequency. That will be 0.081. Like that, we can get the frequencies for each and every class, every cut point group. Okay, and then get the relative frequency by dividing frequency by the number of observations. Okay, as you did in the previous examples. Okay, I've explained how to group quantitative data into specified classes, right? Now I'm going to discuss when to use each of the three grouping methods. Okay, I already discussed to you how can we use those three methods and the definitions of them and the examples of each of them, and now I'm going to teach you when to choose from these three grouping methods. Okay, single value grouping. When to use with the discrete data in which there are only a small number of distinct values. Okay, we can use the single value grouping when there are only a small number of distinct values. Okay, we should use it with the discrete data in which there are only a small number of distinct values. Okay, that's when you use the single value group. And then the limit grouping. The limit grouping we can use when the data are expressed as whole numbers and there are too many distinct values to employ single value grouping. We are using limit grouping when we cannot use single value grouping because there are too many distinct values to employ single value grouping. Okay? Alright. And then the cut point grouping. We use cut point grouping when the data are continuous and expressed with decimals. Okay? For the first two methods, single value grouping and limit grouping, we use those two methods with discrete data, with whole numbers, and single value grouping we use that with discrete when the distinct values are small, and limit grouping we use when the distinct values are large. And for cut point grouping, we use the cut point grouping when the data are continuous and are expressed with decimals. Okay, those are the three clear differences between these three grouping methods, so that you can choose when to use each and every method, okay, with respect to the data set that you have. As I mentioned at the beginning of this lesson, grouping of the observations should be done before organizing and summarizing data. Okay, now we are finished with methods of grouping. So let's move on to the methods for graphically displaying quantitative data. Okay, there are three common methods of graphically displaying quantitative data. They are histograms, dot plots, stem and leaf diagrams. Okay, the three common ways of graphically displaying quantitative data are histograms, dot plots, and stem and leaf diagrams. Okay, now let's begin with histogram. The histogram is a graphical method, basically graph with horizontal axis. Represent quantitative data. The vertical axis represent the frequencies or the relative frequencies or percents. Okay, the frequency of each class on vertical axis is represented by a vertical bar, and this bar has a height equal to the frequency value. Okay, the height of the bar equal to the frequency value or the relative frequency value. Okay, every bar should touch the bars to its either sides. Okay, all the bars should be touched. Okay, so that they are touched each other. That is a characteristic of a histogram. Okay, if you have used single value grouping method to group the data, we should label the bars using the distinct values of the observations, and this label should be centered under its bar. Okay, that is the convention of doing it when we are using single value grouping and when we need to draw a histogram for single value grouping. Okay, if you're using limit or cut point grouping, we should label the bars with the lower class limit or the lower class cut point. Okay, that is the convention. If you're using the limit or cut point grouping, we should label the bars with the lower class limit or the lower class cut points. I hope you guys understood how to use histogram for single value grouping and limit grouping and cut point grouping. Okay, now let's see how to construct a histogram. The first step is to obtain a frequency, relative frequency, or a percentage distribution of the data. You know how to obtain frequency or the relative frequency, right? Okay. And the second step is to draw a horizontal axis on which to place the bars and a vertical axis on which to display the frequencies or the relative frequencies or percents. Draw a horizontal axis on which to place the bars and a vertical axis on which to display the frequencies. And then the third step is to, for each class, construct a vertical bar whose height equals the frequency. For each class, construct a vertical bar whose height equals the frequency of that class. Okay. And then the final step is to label the bars with the classes. The horizontal axis with the name of the variable and the vertical axis with the frequency or the relative frequency or the percentage, the measure that we are using. Okay, label the bars with the classes, the horizontal axis with the name of the variable, and the vertical axis with frequency or relative frequency or the percentage. Okay, that is how we are constructing histogram. That's the 4-step procedure. To understand this procedure further, let's see an example. Okay. This is a continuation of the example that we have done for the single value grouping. Okay. We already obtained this table before when we are doing examples with single value grouping. Okay. So for part A, that is, we need to get the frequency histogram. We need to draw a frequency histogram. Okay. Here the graph with blue bars is for part A. In this graph, this one, yeah, this one, yes. In this graph, the vertical axis is the frequency and the horizontal axis is the number of TVs. The first bar, let's consider the first bar is of height 1 because the frequency is 1. Okay, and the second bar is of height 16 because of the frequency equals to 16. Likewise, we can draw the graph with respect to the frequencies of each distinct value. Okay, the orange colored bars are for the relative frequency histogram. The second bar, which is part B, the relative frequency histogram. It has been drawn following the same procedure by drawing the bars for each class using the relative frequency as their heights. Okay. As an example, for the first one, 0, it's 0.02. For the second one, it's 0.32, like that. It's very similar to the one that we did in the part A. But the only difference is that we're using relative frequency instead of frequency. The next example that we are going to use is from the frequency, the relative frequencies table that we used to get the cut point grouping. Okay, this is the table. We already completed this for limit grouping, right? The limit grouping, I'm sorry, for limit grouping. Now look at the frequency histogram. The frequency histogram has the blue bars. Here note that the horizontal axis starts from 30, right? And it ends at 100. Okay. Alright, this is the frequency histogram for limit grouping. As you can see, from 30 to 39 there are 3, so the height of this first bar is 3, and from 40 to 49 there is 1, so the height is 1. As like that we can calculate, we can draw the histogram and draw each bar with respect to each class, like that. Yes, and then the graph with orange bars, it's this. The second one, the graph with orange bars, it represents the days to maturity with respect to the relative frequency of each class. For an example, in the class of 30 to 39, the relative frequency is 0.075. So the height of the bar is 0.075. Like that, we can draw each and every bar with respect to each and every class by using their relative frequency values. Okay, right. The third example is the example that we use for cut point grouping. The weight of 18 to 24-year-old males. There are 37 males, as you remember. This is the graph. This is the table that we obtained for Cutpoint grouping example. We already calculated the frequency and the relative frequency. Now look at the frequency histogram, which has the blue bars. Here note that the horizontal axis starts from 120 because it's not possible to make it from 0 because the group is going to start from 120. Okay, as there are no data on those values from 0 to 120, there are no values. So for a better representation, we are going to start with 120 and represent it like this. Okay, all right. The definition is the same as for the frequency and for the relative frequency. For the height, we are using frequency, and in here the graph with orange lines, we are using relative frequency for the height of the group. Okay, it's very similar to other two methods when we are drawing histograms. Okay, the next method of organizing quantitative data is dot plot. That is a whole new method. First of all, we learned histograms, and now we are using dot plots. The definition of a dot plot is a graph in which each observation is plotted as a dot at an appropriate place above a horizontal axis. Observations having equal values are stacked vertically. Okay. All right, let's move on to the procedure of constructing a dot plot. There are three steps actually of constructing a dot plot. The step 1, draw a horizontal axis that displays the possible values of the quantitative data. And then the step 2, record each observation by placing a dot over the appropriate value on the horizontal axis. And finally, step 3, label the horizontal axis with the name of the variable. Okay. Those three are the three steps of constructing a dot plot. Okay. Now let's move on to an example of constructing a dot plot. This data set is about the prices in dollars of 16 DVD players. Okay, this is the data set of prices in dollars of 16 DVD players. Now we are going to construct a dot plot for this data. As you can see, each and every value has a dot corresponds to its value in the dot plot. As you can see, the values are going from 190 to 230 because there are values in that range. The lowest value I think is 197. It is plotted at the point 197, and then there are three values for 199, so there are three dots for in the place of 199. Like that, we can plot the dot. We can get the plot of the dot plot by plotting each and every value using a dot. Okay, it's very simple as that. Okay, the last method for organizing quantitative data is stem and leaf diagram. This is the definition of a stem and leaf diagram. As you can see, in a stem and leaf diagram, or we call it as a stem plot, each observation is separated into two parts, namely a stem consisting of all but the rightmost digits, okay, and leaf, the rightmost digit. In a stem and leaf diagram, Each observation is separated into two parts, namely a stem consisting of all but the rightmost digits, and a leaf which consists of the rightmost digits. Okay, let's move on to the procedure of constructing a stem and leaf diagram. There are 4 steps. The first step is to think of each observation as a stem consisting of all but the rightmost digit in a leaf, the rightmost digit. The second step is to write the stems from the smallest to largest in a vertical column to the left of a vertical row. The third step is to write each leaf to the right of the vertical row in a row that contains the appropriate stem. And finally, the fourth step is to arrange the leaves in each row in ascending order. Okay. These 4 are the 4 steps of constructing a stem and leaf diagram. Okay, let's move to an example and see whether we can construct a stem and leaf diagram. Okay. Here in this example, we have the data containing days to maturity for 40 short-term investments. We note that these observations are two-digit numbers, right? Thus, in this case, we use the first digit of each observation as stem. Okay, like this. First digit of each observation as stem and the second digit as the leaf. Okay. The stem has numbers 3, 4, 5, 6, 7, 8, 9. 3 to 9. Okay. First, find the numbers begin with 3. Okay. Then put the last digit of each those numbers in front of 3. There are 3 numbers that begin with 3, that is 38, 36 and 39. So we should put 8, 6 and 9 in front of 3 as the leaves, right? Similarly, you can fill the stems and leaf diagram for the rest of the stems. For an example, for 4 we have only 47, so we put 7 in front of 4, like that. Similarly, you can get the values for 5, 6, 7, 8, 9, like that. And then we can arrange those data into ascending order. That is the final step of constructing a stem and leaf diagram. Okay, arranging the data into ascending order. For an example, let's say that 3 has 8, 6 and 9. We can arrange them into ascending order like 6, 8 and 9, like that. Okay. Here is another example. This data set consists of cholesterol level for 20 high-level patients. And the data points, let's see, the data are 3-digit data. So we should take the first 2 digits as the stem and the last digit as the leaf. Okay. Here we have 19, 20, 21 and 22 as stems. We can repeat the way as we did in the earlier example. For an example, for 19, we have 199, so we put 9. For 20, we have 200, 202, 203, 207, 208, 208, and 209. So we can use the same procedure that we used in the early example to calculate this stem and leaf diagram. This is 1 line per stem diagram. We can make it 2 lines per stem diagram, like this. The stem and leaf diagram in A, this one, the first one, is only moderately helpful because there are so few stems. The second diagram, 2 lines per stem diagram, is better stem and leaf diagram for this data because it has more stems. It uses 2 lines for each stem, with the first line for the leaf digits 0 to 4 and the second line for the leaf digits 5 to 9, like that. Yeah, that is how you can create the 1 line per stem diagram and 2 lines per stem diagram. Okay, that will be the end of this section, and I will see you guys in the next section. Thank you very much.